Hello, Assalamu alaikum. Okay, so start with the last thing जो हम लोगों ने कल last time हम देख रहे थे. So let's, if you have some comments or anything from the last uh, session, please go ahead and said something about it. Any question, any remark, anything, whatever. You can write in the chat, you can raise your hands, and then okay, if we get time, we can discuss the application. Otherwise, next time I will try to discuss the application as well, or we can discuss the applications in our Discord group, because today I have a different agenda. One of the agenda of today's talk is the dimensions. So let's make it clear that what is means by the dimensions, and what is means by the dimension of a shape. Shape की dimension क्या है या objects की dimension क्या है, and we what we call those objects, and and also we see um, the product of shapes. Today the main topic is product of shapes, and also second thing, so when, because I'm talking about dimensions and I'm also talking about the dimension of the shapes, so shapes are sitting in the ambient space. So how they are sitting mean, when they intersect, when they do not intersect, which dimensional objects intersect with which dimensional objects, and for example, if the shapes are moving, then how can they avoid the collision or the intersection. So these are the things which is in the agenda. So Gautam, everybody is come aa chuke hain, या there are some person also coming,
So,
कुछ लोग.
so far we have 28 participants. So there's still people who haven't joined yet. I guess I'll just send over the link via email as well. But I guess we can start.
Okay, so let's start with the dimensions thing. Okay, again, my request with you people is please ask as many questions and as you can, and please um, comment, give remarks, give, for example, if you have some examples you want to share, you can share. Okay, so let's start with the dimension. So dimension is actually the number of values required to specify the points in some space. Okay, the number of values required to mention or to represent. Okay, you have some space. So for example, uh, I have this space. Let's suppose there is only, we have a space which consists of only one point. So in this case, I do not need anything. I do not need any value to represent this point. So I say that the dimension of this point is 0. So if we move this point, we have a space which can be a line. So in order to mention any point, Yes, you can say uniquely, but it does not. It does not require uniqueness. They may change. The uniqueness can change. So, but this is important that the number of values required. Uniqueness does not imply is not necessary. So, when we have a line, so in order to represent a line, we require one value to represent the points. For example, if this is a point, some point, and I say that this is a point on the line, and I call it, I name it 0. And all the points on the positive axis, I name them with the positive real numbers. On the right side, I name them with the positive real numbers. And on the negative side, I name them with the negative real numbers. So for any point, I use one real number on this space. So, so this to specify a point on this space, I need one value. That's why we call that the dimension of this line is 1. So in plane, we need 2 points to specify a point. To specify a point, let's suppose first I made 2 lines. I call them x-axis and y-axis. This is x-axis. This is x-axis. This is y-axis. So then, if I have any point in the plane, I need 2 points to represent it. Okay. Let's suppose A and B, 2 real numbers I need. And I know that these 2 real numbers are the distance of this point from the x-axis and the y-axis. Okay. Since this space plane, yeah, this is shortest distance. You are right. This is the shortest distance. Um, so in plane, I need 2 points. So the dimension is 2. So similarly, when we are in a space, which we call 3D. So for to specify a point in 3D, I need 3 points. And I make 3 perpendicular lines, call them x-axis, y-axis, and z-axis. Let's suppose this is x-axis, this is y-axis, this is z-axis. And in order to specify any point, I need 3. Let's suppose we have some point. So I need 3 real numbers to specify this point in the space. Its distance from x-axis, xy plane, its distance from the yz plane, and its distance from the um, yz plane, xy plane, and xz plane. So this distance is z, this distance is y, and this distance is x. So since we need 3 points, so we call it the 3-dimensional space. And so on. So likewise, so we have an n-dimensional space means that we require n elements x1, x2, to so on, xn to specify a point in that space. ठीक है? So अगर आपको n real numbers require हो उसके points को specify करने के लिए, locate करने के लिए, represent करने के लिए, then you say that the dimension of that space is equals to n. Let's have some space x and you have some point p, and the dimension will be n. So any question related to dimension? So first, this is very important thing. So dimension is kya hai? So dimension is just the number of values required to represent a point in the space. Okay, is it clear? Is this concept is clear? Any remark, anything, please? Yeah, dimension zero means a point, just a point. So when I'm saying space, so I'm I does not means that I'm sitting in any other space like a universe. So universe is a space, okay? So I'm just imagining that all things are universe. हर चीज जो है वो universe है, ठीक है? I'm not saying that this universe is sitting in some other bigger thing. So when I'm saying a space, so let's suppose if my space is a point, so everything is point. Okay? And how many numbers I need to represent a point? I need zero. I'm not saying that this point is sitting in some other space. Similarly, when I'm saying line, so I'm saying this line is the space. This line is the universe. Every points in the line can be represented by one real number. ठीक है ये बात बड़ी इंपॉर्टेंट है सो व्हेन आई एम सेइंग पॉइंट और लाइन or a plane, I'm not saying that they are sitting in some other bigger dimensional space, but yes, if they are sitting in some other dimensional space, then they are also there again, they are again in it has the same dimension. So point has the same dimension, point has the dimension zero. So now I'm coming towards the other thing. I applications, but I don't know about the fractional. And at the moment, I know the positive, the non-negative integers. Yes, now I'm coming to this side. K when you say a 3D object is in 4D or 4D object is in TD, so you're saying just like we draw a 3D object on a 2D plane. Okay, so when we are drawing a 3D object on a 2D plane, we are just projecting that 3D thing in the 2D plane. Or we can draw a 4D object on a 3D plane, which means that we are projecting the 4D object on a 2D plane. Like for example, we are in a 3D space, and our shadow, when our shadow is on the floor is a two-dimensional thing. So the shadow is the projection of ourselves. Okay? Or you can say a drawing of ourselves on the plane. Clear? So now I'm saying, okay, for example, if we have a bigger space and illusion, there is a proper way. You cannot say yeah, you can say it's an illusion, like, but there is a proper way of doing the projection. So there is a proper definition of a projection, geometrical meaning of the projection. When you say this is a projection of some object, of some bigger object. Okay, yes, you cannot depict all the properties of the main shape by only uh, studying the projection. You need some other things as well. ठीक है, so projection से you can say illusion in this sense कि आप projection से आप उसके बारे में exactly सही तरीके से जान नहीं सकते, क्योंकि फॉर एग्जांपल अगर 3D ऑब्जेक्ट है, तो ऐसे 3D ऑब्जेक्ट्स हो सकते हैं जिनको आप डिफरेंट एंगल्स के साथ प्रोजेक्ट करें. अगर एक्स वाई प्लेन पर प्रोजेक्ट करें तो यू विल गेट सम अदर शेप, एक्स वाई जेड प्लेन पर प्रोजेक्ट करें यू विल गेट सम अदर प्लेन, और एक्स वाई प्लेन पर प्रोजेक्ट करें यू विल गेट सम अदर प्लेन, सम अदर शेप. सो द थिंग इज के जो मुझे अब बात बतानी है, तो आ गया मेन के डायमेंशन, आपकी मुख्तलिफ स्पेसिस की डायमेंशंस क्या. अब एक स्पेस के अंदर जो ऑब्जेक्ट्स होते हैं, जैसे लाइन सेगमेंट की हम बात करें, दिस इज अ वन डायमेंशनल ऑब्जेक्ट. सो लाइन सेगमेंट के अंदर जो ऑब्जेक्ट्स बैठे हुए हैं, या इसके अंदर जो मौजूद है, या जो इसके अंदर इम्बेड हैं, या जो इसके अंदर इमर्स्ड हैं, वो आपके पास कैसे हैं. एक तो आपके पास पॉइंट्स, पॉइंट जीरो डायमेंशनल ऑब्जेक्ट्स इसके अंदर बैठे हुए हैं, या फिर इसके अंदर आपके पास ऐसी लाइन सेगमेंट्स हैं, या टुकड़ों टुकड़ों में लाइन सेगमेंट्स हैं. सो जो लाइन सेगमेंट्स हैं, दे आर ऑल्सो ऑफ वन डायमेंशन. ये भी आपके पास वन डायमेंशनल ऑब्जेक्ट. सो लाइन के अंदर जो आपके पास मौजूद है, वो जीरो डायमेंशनल या वन डायमेंशनल ऑब्जेक्ट्स है. इसी तरह जब आप प्लेन पे आते हैं, सो प्लेन में आपके पास जो ऑब्जेक्ट्स मौजूद हैं वो है लाइंस एंड पॉइंट्स एंड स्क्वायर्स एंड सर्कल्स एंड डिस्क्स ट्रायंगल्स, हमने रेगुलर पॉलीगॉन्स देखे, पॉलीगॉन्स देखे. सो दे आर सिटिंग इन अ प्लेन ये सब आपके पास प्लेन में मौजूद है. बट इनकी डायमेंशंस क्या है, डिफरेंट चीजों की डिफरेंट डायमेंशन. तो अभी फिलहाल इस स्क्रीन को ले लेते हैं एज ए प्लेन, कि ये स्क्रीन जो है ये हमारी प्लेन है. ठीक है. और ये हमारे पास इसमें डिफरेंट ऑब्जेक्ट्स हैं. अब ये जो डिफरेंट ऑब्जेक्ट्स हैं, ट्राइंगल बनाया हमने, और स्क्वायर है, रेक्टेंगल है, पैरेललोग्राम है. इनकी डायमेंशंस क्या है, व्हाट आर द डायमेंशंस ऑफ दीज शेप्स, इन शेप्स की डायमेंशंस क्या है. दिस इज वेरी इंपॉर्टेंट थिंग. अगर इसमें लाइन मौजूद है तो लाइन की जो डायमेंशन है दैट इज 1. थ्री डी स्पेस वी कॉल थ्री डी स्पेस, स्पेस ही कहते हैं हम उसको. जनरल नेम आगे फिर स्पेस ही सबके लिए यूज करते हैं. 4D के लिए भी 4D स्पेस, 5D स्पेस एंड सो ऑन. अच्छा, अब यहाँ पर, अब ये जो ट्राइंगल है, ये जो मैंने बनाई है, ये कर्व टाइप है. ठीक है. मीन सॉरी, कर्व भी अभी मैं डिफाइन करूंगा. कर्व भी 2D में आपके पास इस तरह की भी ऑब्जेक्ट्स मौजूद है, पैराबोलाज भी मौजूद है, आपके पास एलिप्सिस भी मौजूद है. ठीक है. सो ये जो ट्राइंगल्स हैं, इनकी डायमेंशन क्या है, व्हाट इज द डायमेंशन ऑफ दिस ट्राइंगल, what is the dimension of this ellipse, what is the dimension of the curve, what is the dimension of the circle. So the dimensions of all these, okay, the dimensions of all these objects or shapes are one dimensional. These are one dimensional objects. Now I will tell you why we say that all these objects are one dimensional. I'm telling this, what we call the flat disk. So first there are points. So points are all zero dimensions. These curves, lines, these are one dimensional. Okay, how, first the question is how you define the curve, or why we call this curve a y dimension. So whether you have a circle, whether you have an ellipse, whether you have a parabola, whether you have some irregular shaped curve. So when I take a very small piece of the curve, let's suppose I take this very small piece of the curve and I zoom it and then look at, so it will look like a part of a line. It looks like a line segment. Okay, when I zoom it and I see this, so it will look like a line segment. It look like a part of a line. So that's why this is the definition of a curve. First the definition of a curve, the smooth curve. The definition of a smooth curve. Smooth curves, I means not, uh, they do not have cusps like this. They do not have corner points. Because when we have a corner point, and for example, if I take this part, so this does not look like a line segment. It look like this, which is not, you cannot say that this is a part of the line segment. But for example, if I take this part, it, and I zoom it, it look like a part of a line. So you can say that these are the piecewise smooth curves. This one, or the curves in which we have cusp, they are piecewise smooth. So I'm talking about the smooth curves. Smooth curves are those in which if we take the a small part, it look like a line segment. It look like a part of a line. And line, I know that it is a one-dimensional thing. So that's why all curves are one-dimensional objects or one-dimensional things, shapes. No, when we zoom it, it would not be a like 3D. Line segment, for example, line segment is a part of a line. And I told you that in order to represent the line, I need only one value. So line is a part of the line segment. That's why it is one dimensional. आप इसको जितना मर्जी zoom करें, you will do, you will get the line segment. So जितना मर्जी zoom करेंगे, you will get the line segment. Okay, you will never get like a 3D object. So whether you have a circle, whether you have a triangle, whether you have any curve, this is one dimensional thing. Now comes, what about these things like disk? If we have this thing जिसको आप square कह रहे हैं, if you have a parallelogram, filled parallelogram, or any regular polygon, all these are, now let's see, let's check. If we take a small piece of this disk, when I take a small piece of this disk, I take this part, so when I zoom it, and see it, it looks like that it is a part of some plane. It looks like a part of a plane. So that's why, and plane is what? Plane is a two-dimensional thing. So from, if you take any small piece from the disk, that small piece look like a part of a plane, and the plane is a two-dimensional. That's why the whole, this disk is two-dimensional. This square, whenever you take a, a part of this square, it look like a part of a plane, and it is actually a part of the plane. So that's why this is a two-dimensional thing. This is a two-dimensional thing. This is a two-dimensional thing, or object, or space, shape. Okay. So in a plane, the things which are sitting are points, curves, different type of curves, whether they are smooth curves, whether they are piecewise smooth curves, they are all one-dimensional. And other are disks, squares, filled parallelogram, filled regular polygons, all are two-dimensional objects. Now let's come to the 3D things. So in 3D, again we have points inside it. These are one-dimensional. We have curves inside it, like a line in the space, any other curve. These are all these are all one dimensional, because again, if you look at the small piece, it looks like a part of a straight line. So that's why these are the one dimensional thing. Similarly, if you take any surface, now like surface of a sphere, I will tell you today what is a sphere. So sphere, you can say the surface of the football. Point is a zero dimensional thing. Zero dimensional. Point is a, sorry, zero dimensional. It is not one dimensional. Sorry. Thank you. It's a zero dimension. Curves are one dimensional. Now in 2D, there are two dimensional objects. As I say sphere, when you take a part of a sphere, if you cut a part of a sphere, and you will look, this will look like that it is a part of some plane. It looks like that it is a part of some plane. So that's why we call it the two-dimensional. This is a two-dimensional object. Okay. And there are some three-dimensional objects as well. For example, if we have a solid cube, for example, if I have a cube which is not hollow, but it is filled. So then when I take a small piece from inside this, and I will look into it, so it will look like that it is a part of some 3D. Okay. So since 3D, um, 3D space, as it does not have any specific name, we call it 3D space. So because it look like that it is a part of, you can say this is R3. अच्छा, इनको आप point को आप R0 कह सकते हैं, जो line है you can call it as an R is a set of real numbers. Actually the set of real numbers, why we call them like this, because the lines, all the elements of the set of real numbers corresponds one to one fashion with the points on the line. Every point is representing by a real number. Every real number lies in some on the line. And similarly, when you have plane, we call it R2, R3, and so on, R4, and so on. Okay, and Rn, because we are taking n real numbers to specify a point in the n dimensional space. So the solid cube is called the three dimensional object. Okay, or the solid sphere. If I take a sphere which is solid, mean it is not hollow from inside, it is filled sphere, then we call it the three-dimensional object. So what is the name of these? So the one-dimensional objects or the shapes are called as curves. Two-dimensional shapes, we call them surfaces, and three-dimensional and so on, these are called manifolds, n-dimensional manifolds. This is a generic name for everything. Curve is a one-dimensional manifold. Surface is a two-dimensional manifold, and so on. Because real is a complete set. It has no gaps. This is a very technical thing to see these things, that this is complete. This is an advanced thing. But R is complete. The real line is complete. There is no holes inside it. So that's why we there is a one-to-one correspondence between the points of the line and the real R. That's why. And whenever you take any n-dimensional space and you take n real numbers to specify that point, so that's why we call them Rn. Rn as a set, you know that yes, point remains a point, because Rn, why I'm calling it Rn, because I'm taking n real numbers, and Rn is a set which is a consist of n tuple of real numbers. Okay. So this is an important thing. So what does the definition of the manifold then? N-dimensional manifold. So I'm not giving you the technical definition, but um, you can say an informal definition of a manifold. Yes, here we are talking about the width of the line is 0. If I'm talking about plane, the plane has no um, uh, width. Its width is 0. So this is something like this. Okay. So n-dimensional manifold. So we say that um, this is an informal definition. Otherwise, the technical definition has so many things. But since you are younger students, you do not need you have not studied the technical things up till now. So the n-dimensional manifold is an object or a shape which locally look like our n-dimensional space Rn. Okay, which locally look like n-dimensional space Rn mean it look like it's a part of the n-dimensional space. Like for example, you all know that we are living on a Earth, and the earth is is a sphere. This is a spherical object. Okay, but when we look around ourselves, it seems that we are on a flat surface. We are on a plane. So this means that if we take a small piece of the sphere or the earth, it seems that it is a part of some plane, and plane is two-dimensional thing. So that's why this sphere is a two-dimensional manifold, and the two-dimensional manifolds we call them surfaces. So locally, globally they are very different objects, but locally they look like uh, look like the n-dimensional object, n-dimensional space. Okay, so is it clear now? Okay, what is a manifold? So if anybody have any confusion or any remark, please tell me. I'll make it clear more. By n dimension. So when I'm saying n dimension, so n dimension means n is any uh, 0, 1, 2, 3, up to so on, anything. So the dimensions are not restricted to 3 or 4 or 2. So there are, you can say any dimension, 0, 1, 2, 3. That's why I'm saying n dimension. N means that it can be one dimension, it can be two dimension, it can be three dimension. So three dimension manifold will be an object or shape which locally looks like a part of 3D space, R3 की तरह लगेगा. One dimensional manifold which we call a curve, it locally looks like a part of the line. ठीक है? And n means any arbitrary. You cannot when you take specific one dimension, the one dimension, any curves are the one dimension manifold. Two dimension manifolds are the surfaces, spheres. Say for example, sphere is a two dimensional manifold. Yes, it is not a three dimensional object. It is sitting inside a three dimensional object. When I'm saying sphere, sphere जो हमने एग्जांपल अभी मैंने दी थी, मैं दोबारा sphere की एग्जांपल दे दूं कि sphere जो जिसपे हम हैं, हमारी अर्थ जो है वो सफेयर है, बट हमें लगता क्या है, what it looks, it seems that we are sitting on a flat thing. It's not a spherical thing, because when we look around, everything is flat. So this is the beauty of this shape, that it locally look like a part of a plane. Globally, when we go outside and see itself, then it is a sphere. So similarly, so this is the definition of, since it's look like a plane which is a two-dimensional object, so we can say that it is a two-dimensional object, and sphere is sitting inside R3 is a three-dimensional space. So if anything is sitting inside a three-dimensional space, it doesn't mean that it is a three-dimensional thing. It is a three-dimensional object. For example, points are sitting inside inside R3, but we do not say that a point is a three-dimensional object. Similarly, the spheres are two-dimensional object, but they are sitting inside the three-dimensional space R3. Okay, is it clear now? Ahmed Usman. Okay, good. Anybody have any other question? So when I'm saying n-dimensional, it means any. Okay, so I'm taking I take, that's why I start with examples. I take examples of, I start from the zero-dimensional things. I take plane में मैंने zero-dimensional objects भी दिखाए आपको, one-dimensional objects भी दिखाए. So objects mean यहाँ पर ये curves are one-dimensional manifolds. They are curved. These disk is a two-dimensional object. It's a surface. Okay. Similarly, when we are in R3, we have a zero-dimensional manifolds, we have one-dimensional manifold, we have two-dimensional manifold, and when we have we have three-dimensional manifold. So last बात मैं करके इसके बाद हम नई मीटिंग में जाते हैं. Note कि in n-dimensional space, no object of higher dimension is present, which means that, for example, in 3D, for example, in 3D, there is no object here, no manifold of dimension greater or equals to 4 is जो more technical word है वो embedded है, इसलिए मैं इधर embedded लिख रहा हूँ. Is embedded in, is embedded. Okay. No, Zainab, sphere is a 2D. It sits, it is embedded in a 3D space. ठीक है? It's a surface. If it is filled, अगर हम बात करेंगे filled sphere की, अंदर से भरा हुआ है, ठीक है? Filled है, then it is a three-dimensional thing. If we are taking, I name this, अभी मैं इसको एक नाम दूंगा, जो कि ball का नाम दूंगा. So sphere और ball में थोड़ा सा फर्क होता है. So I will tell you. So after this the second meeting started, I'll start with the basic building blocks of the manifold. And in a tuple, every element is a real number. Okay, just because to make it different, that n-dimensional manifold need not be in an n-dimensional space. It can be in some high dimensional. So k is a number which is greater or equals to n. Okay, is it clear, Fatima? If you're asking Fatima, I don't know who is asking this question. Sorry.
Sir, I didn't ask that question. I have another question though.
Okay. Yes,
I just
Fatima.
wanted to confirm that the sphere जो आप कह रहे थे वो it's in a 3D space but the shape itself is 2D, or was it the other way around?
Yes, you're right. This is the thing I'm saying, that the shape is a two-dimensional. So shape की जो dimension है, please understand this thing. What does mean by the dimension of a shape? Dimension of a shape. So dimension शेप की देखने के लिए आप उसको लोकली चेक करें कि वो लोकली से मुराद ये कि टेक अ स्मॉल पीस ऑफ या पार्ट ऑफ दैट शेप एंड चेक कि that part look like what it, whether it look like a line, whether it look like a point, whether it look like a part of a plane, whether it look like a part of some space. So it tells you the dimension of the shape. So since when you have a sphere, and when I take a small part of that sphere, when I take this part outside and I look it, or I'll show to anybody, he does not recognize that it is a shape, it is a part from a sphere or it is a part of a plane. Okay, so this means that it look like a plane. So this means that this object sphere locally looks like a part of R3, the three-dimensional space. Okay. So K is a higher dimensional space which contains n-dimensional manifolds. Yes, K can be higher or can be equals to n. Yes, K is less or equal, greater or equals to n. No. Doesn't means that it is globally 3D. So the dimension, there is no concept of local dimension or global dimension. I'm saying that globally it is not a plane, but locally it is a part of it. It looks like a plane. Okay. It sits inside, it is embedded in 3D space. Yes, good. I hope we can more talk. If somebody has still confusion about these dimensions, we can talk later on. But I have so many things. So first, the basic building blocks. इनके जो आपके जो manifolds हैं. अब मैं जनरली शेप्स के लिए वर्ड यूज कर रहा हूँ मैनिफोल्ड्स का. इसमें सब कवर हो जाता है, कर्व्स भी कवर हो जाती है, सरफेसेस भी, पॉइंट्स भी, एवरीथिंग इट इज कवर्ड इनसाइड दिस. ठीक है. Okay. Rahid Ali, please do not write on the board. So there are some building blocks. Okay, so building blocks means that these are the basic manifolds, and all other manifolds can be built up using some operations. So first is the definition of n sphere. So whenever I'm saying n, so I'm saying because of the generalization. Okay, so n sphere, um, but before n sphere I want to tell you n ball. It is more general thing. So n ball, we can denote it by bn, superscript n, and it consists of all those points in Rn, x1, x2, up to so on, which satisfy this inequality, x1 square plus x2 square plus so on plus xn square is less or equals to 1. Okay, so let's see. I make a table of different dimensions and different balls. Let's here I'll write the dimensions, and here I'm making the balls. Let's start with the 0 dimension or a one dimension is okay, because 0 dimension, we do not have anything because it's a point. Okay, so one dimensional, in a one dimension, we the definition of b1 becomes all those points, all those real numbers which satisfy this thing, that x square is less or equals to 1. So ये simple inequality hai. You have studied this thing, x square is less or equals to 1. So all those points from -1 to 1, they satisfy this thing. Okay, so b1 is a line segment from -1 to 1, or an closed interval from -1 to 1. Now let's come to dimension. So in a 2 dimension, b2, it consists of x1, x2, such that x1 square plus x2 square is less or equals to 1. So what is this thing? So this is a disk centered at origin with radius 1. So one radius ये आपके पास, one radius की जो आपके पास disk है, that is the ball B2. And if we take 3, so for 3, you will get B3 will be all those points x1, x2, x3, such that x1 square plus x2 square plus x3 square is less or equals to 1. I just want to change the color so that it looks, so in R3, okay, so this will be filled inside the all points which satisfy these conditions. So actually this thing x1 square plus x2 square plus x3, this is, you can say this is a distance of any point from origin. So in other words, I'm saying that B3 consists of all those points whose distance from origin is 1 or less than 1. Similarly, B2 is all the points in the plane whose distance from origin is less or equals to 1. And here also all those points whose distance from origin is less or equals to 1. Okay. So now tell me what will be the dimension. Now this dimension is different. This is the dimension I'm saying I'm taking in the one-dimensional space, in the two-dimensional space. So tell me, what do you think? What is the dimension of n ball? What is the dimension of n ball? Answer. Mean, for example, if you're taking B1 ball, which is a line segment, so what is the dimension of the line segment? Yes, n dimension, you are right. The dimension of the n ball is n, because when we have B1, B1 has line segment, which is one segment. When we have 2, so we have a disk, which is 2 dimension. We have B3, so we have a solid ball, the solid ball, then this is the dimension 3, and so on. So n dimensional ball has dimension n. Next are spheres. I'm writing it n minus 1 sphere. I'm telling you later on why I'm writing n minus 1. So what is the definition of n sphere? We write it like this: Sn minus 1. This is consists of all those points of Rn. Now from here you can see that the sphere is sitting in Rn. Sn minus 1 sphere is sitting in Rn, such that the sum of these real numbers, the squares of these real numbers, is 1. I varies from 1 to 1. The sum of the squares will be equals to 1. So again, let's see in different dimensions. So Sn minus 1, and I'm taking here dimension n. So when I'm taking one dimension, so in the one dimension, so what are those points? So it consists of all those real numbers whose square will be equals to 1. So there is only two numbers minus 1 and 1. So only these two numbers, I'll make it with the red ones. Minus 1 and 1. Only these two numbers satisfy this. So actually S0 is consist of only 2 points, minus 1 and 1. Okay. Then we have two dimension. I will take the questions, just I'll complete this and I will take the questions. Gautam, please note these questions if you can from the chat, and then you will ask me later on.
Sure, sir.
So in a two dimension in plane, so S1, there is S1 whose dimension is 1, and it consists of all those points whose sum is equals to 1. The sum of the squares will be equals to 1. And this is, you know that this is the circle. Only this curve, this red curve is the circle. These are the only points whose distance from origin is equals to 1. Here the distance is equals to 1. And similarly, for example, if we have three dimension, so in a three dimension, S2 will be the sphere. Only the outer part, not the inside one, because the inside one has the distance which is less than 1, and the outer parts consist of those whose distance is equals to 1. Okay, so this is S0, this is S1, this is S2, and so on. Question: what is the dimension of Sn minus 1? Sn minus 1 की dimension क्या होगी? The dimension of Sn minus 1, yes, you're right. The dimension is n minus 1. Because here, for example, the sphere consists of 2 points. Points की dimension क्या होती है? 0. So they are embedded in these 2 points are inside the line, inside the one-dimensional line, but its dimension is 0. Similarly, circle lies in a plane. Circle plane में मौजूद है. It is embedded in the plane, but it has dimension 1 because I told you that when I take a small part, it looked like a part of a line. So it has dimension 1. And when you have a sphere, it has dimension 2.
Excuse me, I have a question.
Yes, Jiran.
Isn't the dimension of an Sn n minus 1? So for dimension 1, S of n, n's dimension was n minus 1.
Yes.
And so the dimension of S of n minus 1 should be n minus 2.
No. I write n minus 1 because of the dimension thing, because I know that the dimension is 1 less the dimension in which it is sitting. So that's why
Oh,
I write n minus 1. Okay. So that's why I'm saying that why I will tell you later on why I write n minus 1, because of the dimension of this object or this shape or this manifold is n minus 1. It is embedded in n dimensional object in around in n dimensional space, but it it's uh, it's इसकी अपनी जो dimension है, it is n minus 1. Okay.
yes.
G, any other questions from the chat? I have not seen the chat, so please, Gautam, if you can tell me any questions from the.
Yeah, so Rahim had another question, Rahim, am I taking that name correctly? Which is that, do we
Yes.
need unity or can it be any fixed radius for the sphere?
Okay. At the moment, we are taking the unity, we are taking one, and now I will tell you we can in topology. I have in the last class I discussed you with the term topology. Topology is the study of shapes, but here the objects are, you can say, we also call it rubber sheet geometry. So rubber sheet geometry, in this geometry, if you have two things and two shapes and you can deform one shape into the other shape, then those two shapes are actually the same. Okay. So when, for example, you have take a circle with radius 1, or if you are taking a circle with radius, let's suppose 5 or 10 or 2, whatever, so then they are both are the same object in topology. Okay. You can expand it. आप इसको let's suppose that this is a rubber sheet type of the circle. So if you expand it, so अगर आप इसको expand करेंगे, you can make it a circle of any radius, or if you shrink it, you will make it a circle of any smaller radius. Okay. So that's why these two are. So the only thing which is not allowed, that you just transform, you deform the one object to the other by stretching, shrinking, but you cannot tear, you cannot make a hole, you cannot cut. So these things are not allowed because they distort the shape of the object. So I'm saying about the one dimensional thing, but for example, if you are taking two, if we are taking radius of 2, 3, and so on, all are equivalent. So that's why we are taking only the unity thing. Okay, if you have any question, please ask me. The same thing, you can say it's a hyper volume. So the terminology, the general terminology is volume. So one dimension में आप उसको length कह देते हैं, टू डायमेंशन में एरिया कह देते हैं, थ्री में आप उसको वॉल्यूम का ही नाम देते हैं, कुछ लोग इसको हाइपर वॉल्यूम का भी नाम देते हैं 4D में, बट एक्चुअली द थिंग इज वॉल्यूम, एंड एक्चुअली द थिंग इज द स्पेस कवर्ड बाय द ऑब्जेक्ट. ऑब्जेक्ट ने जितनी जगह घेरी हुई है, ली हुई है, उस मेन जो एम्बियंट स्पेस है, मेन डायमेंशनल स्पेस में जितनी स्पेस उसने कवर की हुई है, उसकी मेजरमेंट को वॉल्यूम कहते हैं. ठीक है. Okay, so if you have no question, then I want to move forward. So I say that these are the building blocks. These two things are the basic building blocks, and the main thing here is one more thing, is that I'm talking about the boundary, and I represent it by this symbol, that the boundary of Bn's is Sn minus 1. ये जो आपके पास डिस्क की जैसे मैंने बात की, या मैंने बात की थी लाइन सेगमेंट की -1 to 1, ये B1 था आपके पास, और जो S0 था वो क्या था, ओनली द 2 points -1 and 1. So these are the boundaries of this So first question would be, what will be the boundary? Boundary of any manifold. So boundary is that part of the object. Uh, you can say that you can go in or go out from that. For example, if you take a smaller part from here, so this is a disk, okay, and you take, I'm saying that the circle is the boundary of this disk. And why this is a boundary? Because if I take a smaller part from this part, so so the part of the disk, the part of the boundary, I say this is boundary because this zoom thing has some part of the object as well as some part of the complement of the object. Okay, so this part has, but whenever I come here, so I can take a part in which the only the part of the disk is inside, this is enclosed, this, you can say this part is enclosed only the points of the manifold, not outside of the manifold. So boundaries are those points. If you take a smaller piece from there, then that piece contains the part of the manifold as well as the part of the outside of the manifold. I hope now is it clear. For example, here -1 and 1 are the boundaries of this line segment, because for example, if I take a part, because this is a whole line, so when I take a part of the line, so that part of a line, half of the line is the part of the ball B1 and the remaining is not the part of B1. Okay, so all spheres are actually the balls of all the boundaries of the balls. So like disk is a B1 and sphere S1, the circle is the boundary of that. And similarly, if I take a solid sphere, filled sphere, so the outer sphere B2 is the filled sphere and its boundary is the sphere S B3, this is B3 and its boundary is S. So from these building blocks, we can make all different types of manifolds, very complicated and very interesting by the different operations. And one of the operation which we are going to study today is the product operation, or the multiplication of the manifolds or the shapes. Okay, so first I will define what does it means by the multiplication of the shapes. So for example, if you have two manifolds or two shapes x and y, so you have two manifolds or two shapes, we write the product as the same multiplication sign x cross y. Okay, so this x cross y is a shape or a manifold. So when you take the product or if you multiply two shapes or two manifolds, you will get a manifold whose vertical cross section looks like y and horizontal cross section looks like x. So product is of x and y is a shape or a manifold whose vertical cross section look like y. Cross sections, all vertical cross sections will be look like y and all horizontal cross sections will be look like x. Do you know about the cross sections? What does it mean by the cross section, or what does it mean by the vertical cross section? Anybody can tell me? कोई बताएगा? when you cut a shape, yes, by some or a slice, yes, you are right, slice. When you cut a uh, for example, if I have a sphere and I take its horizontal cross section, so the horizontal cross section will be, when I take, let's suppose, like this, so I will get a circle. Okay, I will get a circle. This is the cross section. Or you can take, so cross section is actually, you can say it's an intersection of the shape or a manifold with the plane. ठीक है, प्लेन के साथ जो आपके पास उसकी उसका वो होगा वो, और वर्टिकल प्लेन लेंगे सो वो वर्टिकल, यस वर्टिकल वो होगा, एंड हॉरिजॉन्टल प्लेन लेंगे तो वी विल गेट द हॉरिजॉन्टल क्रॉस सेक्शन. Okay, so do you understand the definition of product?
Yes.
Okay, good. So let's see some examples of products. Let's make some a table. Let's make a table of, let's suppose I have a point, I have a line segment, basic building blocks की बात कर लेते हैं. I have a circle and I have a disk. मैं ये कुछ चार जो है और इनकी इन्हीं के साथ जो है, let's suppose point, we have line, we have circle, and we have a disk. Okay. So when we take a product of point with a point, we will get a point. Okay, when we get a point with a line, we will get a line. When we get with a point with a circle, again we will get the circle. When we point with the disk, we will get the disk. Okay, next, if we take a product of line with a point, then what will you get? You will get a line.
Line.
Yes. Next, if you take the product of the line segment with another line segment, what will you get? You will get a rectangle. So the horizontal cross sections are the lines, the vertical cross sections are the lines. Okay. Next, when you take product of a line with the circle, now this time you will get an object like this. This is a cylinder, because at every point you will have a cross section line and the vertical cross section is circle. Okay. Yes, this is hollow cylinder. This is hollow cylinder. Yes, good. But when we take when we take it's with the solid one, what will you get? This time you will get a cylinder, but this time it is not hollow, it is filled. Okay, let's color differently with the horizontal and vertical. Okay. Okay, next, circle with a point, you will get point. Not point, you will get a circle. Point with a line, so again you will get a cylinder. The horizontal are and the verticals are the lines. And this is a hollow cylinder. Okay, now the interesting one comes. When you take the cross of the circle with circle, now can you guess What will you get? Circle cross circle. Rahim Haq guesses that it is sphere. Saad Naim sphere. Sphere or ball. Sphere, because this is one thing is very important here. That, for example, when you are multiplying the circle with the line, so at each point of a circle, that let's suppose the base circle is this, this blue one is the base circle. So at each point of the circle, you will make a line segment. Okay. And at each point of the line, you can say that there is a circle. So now we have a circle, and each point of the circle, let's suppose this you have a circle. Now at each point of the circle, you have to attach another circle. So if you are attaching these circles on at each points, so now can you guess what will be the situation? क्या बन रहा है आपके पास? What's the shape of this thing? Yes, torus. So this is a torus. You will get, because at every point you will get a circle. So just I'm making a good picture. Okay, so at each point you will get a circle. हर point पर आपके पास circle हो. ठीक है, और हॉरिजॉन्टली भी अगर आप देखें तो भी आपके पास सर्कल है. Good. Now what will we get when we move around a circle with a disk? We will take a product of a circle with a disk. Now what will you get? Filled torus. Zoya says ring. So can you elaborate, Zoya, what does it means by ring?
The torus will be filled, but the torus will be filled. I guess that's a ring.
Okay, so torus, you know that torus is hollow from inside. This is like a tire tube. But if you multiply a circle with a disk, you will get the filled torus, or you can say a donut. Donut is, this is a filled object. So this time you will get a solid torus. Okay, you will not get a hollow, but you will get disks inside it. So this will be filled from the inside. On the outside you have circle, a hollow circle, but from the inside this is filled. Okay, so in this way you will get the whole torus. Okay, lastly, when we multiply the disk with the you are talking about what, Mohammed Ahmed? Hollow tube. When you get the torus is a hollow tube. When you multiply a circle with the circle, you will get a hollow tube. And when you multiply the circle with the disk, you will not get a hollow tube. It will be the filled one. ठीक है? Filled one को हम लोग कहते हैं solid torus. जिसका नाम है वो है solid torus. इसी तरह ये जो भी जितने भी filled हैं ये solid torus है. मैं इनकी वजह आपको बताता हूँ अभी कि क्यों इनको solid क्यों कहते हैं. No, it is not like a horn torus. Horn torus is something else. If you're referring the horn torus, then it is something else. So disk with a point, again, you will get a disk with a line. So this time you will get a solid cylinder, filled cylinder. It will be filled from the outside, and you will get, okay. Next again we have torus, filled torus. Okay, this time I will make upside down, but this is a filled one. So it is a filled torus, you can say. Okay, what about the disk with disk? What will you get this time? Mm, solid ball. Yes, you can say that it is like a ball, because for example, if you take like this, you know that it is solid from the inside. So that this time this is also solid from the, because there is a hole in this picture, there is a hole here. Okay, so but this hole is filled this time. This hole will also be filled this time. There is no hole there because this is a disk, and at each point you again, um, you will get a disk. So this is something, a ball. Okay, so when I draw it, it is something, a ball. Picture, and this time, because at every point this is filled, this is filled, so everything is filled this time. So this is, mm, homeomorphic. Homeomorphic means that you can transform the object to the ball. But this, sorry, I cannot draw this. This is not okay. Just a minute. This is something which is not drawn in. Because I cannot draw this, because this, I'll tell you about this thing कि यहाँ पर क्या होना चाहिए. Before this, I go back to the dimension thing. Let's see कि यहाँ पर क्या होगा. इससे पहले इसकी dimension की जरा बात कर लें कि what will be the dimension of the, if you are taking the product of, sorry, if you are taking the product of two manifolds x and y, what will be the dimension of x and y? So the dimension of x product y will be the dimension of x plus the dimension of y. Okay, so every time you will get here, if you see that it is a zero dimensional thing, it's a zero dimensional thing, so multiply, you will get a zero. So zero dimension thing, this is a one dimensional thing, you will get a one dimensional thing. This is a one dimensional thing, you will get a one dimensional circle. This is a two dimensional thing, you will get a two dimensional circle. So circle with circle, जब आपने circle को, sorry, cylinder के साथ किया, दोनों one dimensional है, 1+1 circle आया. When you are multiplying the circle with the circle, you will get a two-dimensional object. Torus is a two-dimensional or manifold or a surface. So you multiply a circle with disk, you will get solid torus. So one dimension or two dimension, इन दोनों को sum करेंगे, this is a three-dimensional object. So similarly, यहाँ पे two-dimensional object है, you multiply it with the zero dimension, you will get two dimension. You multiply with the one, you will get three dimension. You multiply with the one dimension, you will get three dimension. Now this time, whatever the thing is, this is a four-dimensional. Now four-dimensional thing cannot be embedded or sitting in three-dimensional space. So four-dimensional manifold will at least sit in R4 or above. So we cannot see the picture of this thing. हम इसकी picture को नहीं देख सकते because it's a four-dimensional thing. Okay. So now is it clear that what will be the product of a disk with a disk? It is something which is four-dimensional thing. Um, maybe it is homeomorphic to S4. Maybe I don't know. Oh, sorry, S4, B4. I don't think so. Okay, if you have any question, please. No question. Are there shapes whose product would give us a S2 sphere? Let me think. You are saying that okay, so sphere is itself, you know that sphere is a basic building block. Spheres are basic building blocks. So yes, you can take a product of the sphere with the point, you will get a sphere. So if you take the product of sphere with the point, then you will get the sphere. So if you're saying if there are some one-dimensional object whose product is a sphere, uh, there is no, you can take, you must need some quotient. So हम आगे quotient, मतलब you can describe it as a quotient set, but you cannot describe it as a product set. So building blocks का मतलब ही ये है कि ये किसी के product नहीं है, they are made by themselves, they cannot be made. So यहाँ पे ये जो point है ये multiplicative identity के तौर पे काम कर रहा है. Okay, is this operation distributive? So different questions, distributive है या नहीं है? So distributive with respect to what? Distributive के लिए दो operations होने चाहिए, अभी हमने सिर्फ एक operation पढ़ा है. हाँ, ये सवाल हो सकता है कि is this commutative? यहाँ पर हमने कुछ जैसे मल्टीप्लाई किया था सर्कल को इस लाइन के साथ, और जब लाइन को सर्कल के साथ दोनों दफा सिलेंडर मिला है, बट दोनों सिलेंडर्स डिफरेंट है. ज्योमेट्रिकली दे आर डिफरेंट सिलेंडर्स, सो द प्रोडक्ट ज्योमेट्रिकली द प्रोडक्ट इज नॉट कम्यूटेटिव. बट व्हेन you are in a topology, because you can transform this cylinder to this cylinder just by a rotation, so they are equivalent. So commutative property holds in topology, but in general geometry में commutative इस operation का commutative property नहीं है. ठीक है? So this operation is not commutative in general, means that the product of x cross y is not equals to y cross x in general. पॉइंट जो है आपके पास, जो पॉइंट शेप है, ये मल्टीप्लिकेटिव आइडेंटिटी के तौर पे काम करती है. मल्टीप्लिकेटिव आइडेंटिटी का मतलब ये कि किसी भी शेप को पॉइंट के साथ मल्टीप्लाई करेंगे तो यू विल गेट अगेन दैट सेम शेप अगेन. ओके. Associative, you can ask about the associative property, that is that associative? So the answer is yes, it is associative. Yes, this is a good question that yes, it is not necessary to multiply only two, we can multiply more than two manifolds. So if you want to take three manifolds x1, x2 and x3, you can have, so first you multiply the first two and then you multiply by the third. ठीक है? तो associative property yes mean अगर आप पहले दो manifolds x cross y का product लें और फिर उसका z के साथ product लें, या पहले आप y और z का product लें और उसका x के साथ product लें, so you will get the same. यहाँ पर अगर फॉर एग्जांपल अगर आप पॉइंट का या चले लाइन का प्रोडक्ट लें, लाइन के साथ वो रेक्टेंगल आता है, और रेक्टेंगल को आप मल्टीप्लाई कर दें दोबारा लाइन के साथ तो यू विल गेट अ क्यूब, ठीक है। और अगर आप पहले लाइन को लाइन के साथ मल्टीप्लाई करेंगे so you will get a cube and then you multiply with the point, you will get the diamond, you will get the cube again. So I'm saying the following thing. I'm saying if you multiply a point with a line and then you multiply with a line, so you will get not a cube, you will get a rectangle. Or you multiply first with the lines with the line and then multiply with the point, again you will get the rectangle. So ये तो मैंने एक example दिया, but you can say see that this the associative property holds. One last thing about the product. What will be the boundary of the product manifold? The boundary of the product manifold is it equals to boundary of X cross boundary of Y. So this is a question for you people to think about, that what will be the boundary of the two um, manifolds, the product of the two manifolds. Is it the equals to the product of the boundaries or something else? So if it is equals to this thing, please pictorially आप pictorially इसको prove करके देख के बता दें. और अगर if this is not true, then what is true? वो statement बताएं कि वो क्या है true और उस statement को बता दें कि, और अगर ये true नहीं है तो you can give a counter example as well. Yes, this is how you say that something is not true. Do we have time, Gautam? Because I have a lot of things about related to the intersection of the manifolds inside an ambient space.
So as far as time is concerned, we have run out of time, but I guess it's completely up to the students if they want to stay. Then you can continue. So if we can have some feedback from the students on the chat, if they would want to extend the session, perhaps. So how long would you require for the intersection?
If I go very quickly, then it will can be finished earlier. So बताना मुझे ये था. I want to tell you about, we see that how any manifold is sitting in some ambient space. So generically, so what could be the dimensions of the two sum manifolds or two manifolds inside, so that they cannot intersect, or they, and when they intersect. The second thing, if one manifold is moving, when you say that this manifold will must intersect the other manifold, and when we say that it can escape from intersecting the other manifold. So it's all about the dimension things. कि dimensions कुछ खास किस्म की dimensions होनी चाहिए. वैसे ही आपको अंदाजा होता है कि जैसे फॉर एग्जांपल अगर आपके पास एक रूम है, उसमें आप बहुत सारी चीजें, बहुत सारी बड़े साइज की चीजें रखेंगे, तो आपके पास और अगर रूम का साइज थोड़ा है तो आपको यू नीड सम, आपको बड़ी चीज रखने के लिए बड़ी डायमेंशन चाहिए होती है, छोटी चीज के लिए अगर छोटी चीजें रखनी है तो ज्यादा स्पेस होगी, समथिंग लाइक दिस. सो डायमेंशंस के अंदर, मेन डायमेंशन के अंदर, ये तो हमने देख लिया कि एन डायमेंशनल स्पेस में जो मैनिफोल्ड्स होंगे उनकी डायमेंशंस जो है दैट विल बी लेस और इक्वल्स टू एन, वो एन से ज्यादा नहीं होगी जो उसके अंदर मैनिफोल्ड्स होंगे. बट वो जो उसके अंदर मैनिफोल्ड्स है, हाउ दे आर सिटिंग इनसाइड, वेदर दे इंटरसेक्ट विद ईच अदर और दे डू नॉट. जी राहिल, if you have question please ask me. Okay, again you ask what is manifold. So manifold, in the start I have told you that manifold is an object or a shape which locally look likes a part of Rn. An n-dimensional manifold is an object or a shape which locally look likes a part of Rn. ठीक है, Rn is n-dimensional space. Okay. G, anybody else? So the thing is, do I continue for these things or next time you want in the next class? Okay, let's try to do these things quickly. Okay, so the thing is, when what about the intersection of different shapes in a space? So let's start with in R2. R2 से start करते हैं. So R2 is a plane. So in a plane, if you have two lines, plane में अगर आपके पास दो lines हैं, so tell me whether they intersect or not. जनरली करिए, अगर आपने दो लाइंस कोई पिक की हैं तो क्या वो जनरली इंटरसेक्टिंग होती हैं या नहीं? व्हाट डू यू थिंक? इफ यू टेक टू लाइंस, one is this one, other is this one. जनरली या जेनेरिकली आपके पास equal chance of intersecting and non-intersecting? No, not right, Sayyid Ayan Ali. There is very few chance that the lines are non-intersecting. There is a more chance that the lines are intersecting. So generally, when you take two lines, generally the two lines in the plane are intersecting. And for example, if you have two lines which are which are not intersecting, then you can, if उनमें से किसी एक line को आप थोड़ा सा move करेंगे, for example, if you have two parallel lines, so if I slide it little bit, the one of the line, if I move one of the line a little bit, so it becomes an intersecting line. Okay, so usually generally you have a lines in a plane that are intersecting. So two parallel lines, this is a case of, we can say that, yes, these lines have infinite lengths. Whenever we are saying that yes, these are lines have infinite lengths. Yes, you're right. This plane is infinite. These lines are infinite. They are intersecting. Okay. So when you have a two lines which are parallel, this is a degenerate case. So in a degenerate case, the two lines are parallel. अच्छा, जो लाइंस हैं उनकी डायमेंशन क्या है? यू नो दैट द डायमेंशन ऑफ वन लाइन इज 1, दूसरी लाइन की भी जो डायमेंशन है वो आपके पास है 1, और प्लेन R2 है. 1 + 1 - 2 = 0. इस बात को साथ साथ नोट करते जाए. मैं पहले कुछ एग्जांपल्स दे रहा हूँ, फिर उसके बाद हम आएंगे उस पे. 1 + 1 - 2 = 0. ठीक है. अब अगर हम R3 की बात करें, इन R3 प्लेन में, if you are in a plane and you have two lines, what about their intersection? So in 3, if you have two lines, if we have two lines in R3, now they have more chance of non intersection, क्योंकि इसकी भी जो डायमेंशन है, दोनों लाइंस की डायमेंशन जो है वो आपके पास होगी 1. So 1 + 1 - 3 = -1. ठीक है. So now generally the lines will be non-intersecting. In R3, generally the lines are not intersecting. Similarly in plane, आपके पास plane R3 में आप एक लाइन ले लें और एक प्लेन ले लें. R3 take वन लाइन एंड प्लेन। प्लेन की आपको डायमेंशन पता है कि वो 2 है, लाइन की डायमेंशन जो है the dimension of the plane is 2 and the dimension of the line is 1. So what do you think, whether they intersect or not? It will intersect, and the intersection will be a point. So यहाँ पे भी आप अगर गौर करें 1 plus 2 minus 3 is equals to 0. R3 में एक और केस भी हो सकता है, two planes. If you are taking two planes, what is the intersection of the two planes? Take two planes. Tell me what will be the intersection of two planes? दोनों आपके पास टू डायमेंशन, जनरली आपके पास लाइन होगी। फॉर एग्जांपल अगर आपके पास एक प्लेन ये है और दूसरा प्लेन जो है वो ये है, सो दिस इज द लाइन व्हिच इज द इंटरसेक्टिंग ऑफ दीज टू। ठीक है, ये पीछे इस तरफ बॉर्डर ऑफ है, पीछे भी होगा और ये पीछे भी होगा। सो यू विल गेट अ लाइन। सो सिचुएशन क्या है आपके पास, 2 + 2 - 3 = 1। ऐसे भी प्लेन्स होते हैं जो कि पैरेलल हो, वो इंटरसेक्ट नहीं करते, बट अगेन ये डी जनरेट केस है। अगर दो आपके पास प्लेन्स हैं वो पैरेलल हो सकते हैं, ठीक है। और इसी तरह ऊपर भी आपके पास ये केस भी हो सकता है कि एक आपके पास प्लेन है और प्लेन के अंदर ही लाइन मौजूद है, ठीक है, आपने जो लाइन दी वो उसके अंदर ही मौजूद है, लेकिन अगेन ये भी डी जनरेट केस है, ये भी डी जनरेट केस है, ये भी डी जनरेट केस है। तो फिर जनरल फॉर्मूला क्या है कि कब दो जो शेप्स हैं या मैनिफोल्ड्स हैं वो कब एन डायमेंशनल स्पेस के अंदर इंटरसेक्ट कर रहे होंगे, और जो उनका इंटरसेक्टिंग मैनिफोल्ड है या शेप है उसकी डायमेंशन क्या होगी। सो लेट्स सपोज आपके पास ए एल जो है ये दो मैनिफोल्ड्स हैं विच आर इन आर एन में मौजूद है, ठीक है। सो द डायमेंशन ऑफ के प्लस द डायमेंशन ऑफ एल माइनस एन, इसको हम कहते हैं ओवरफ्लो। ये ओवरफ्लो कहलाता है। ये जो नंबर है डायमेंशन ऑफ के, डायमेंशन ऑफ एल माइनस एन, दिस इज कॉल्ड द ओवरफ्लो। एंड दिस जो हमारे पास रिजल्ट है ये एक्चुअली आपको डायमेंशन के ओवरफ्लो के बारे में ही बताता है। ये आपको बताता है कि कब आपके पास जो है वो इंटरसेक्शन होगी और कब नहीं होगी। which when it is less than 0, what not possible means intersection not possible. Yes, so if overflow is negative, अगर आपके पास overflow negative हो, then generically इन दोनों की जो intersection है, the intersection of K and L is empty, and if the overflow is greater or equals to 0, then generically they intersect, वो दोनों intersect करेंगे, and what will be the dimension of the intersection? This is the overflow. अगर आप एग्जांपल्स जो मैंने की हैं उसको देखें तो वन डायमेंशन की लाइन है और वन डायमेंशन, दिस इज के, दिस इज एम और दिस इज एन डायमेंशनल स्पेस। सो 1 + 1 - 2 = 0। सो 0 is a non-negative number and this is a dimension of the intersecting object, and an intersecting object is a point. सो इसी तरह R3 में आपके पास जब दो लाइंस आपने ली थी, So दोनों lines की dimension 1. So 1 plus 1 minus 3, which is equal to minus 1. So you will get a negative number. So which means the overflow is negative. There is no intersection. And when you're taking one dimension and two-dimensional plane, then it is 0, means you have a point. And similarly, when you have two planes, so 2 plus 2, 4 minus 3, you will get 1, which means the intersection is there is an intersection and it gives you a one-dimensional space. Okay? So this is a theorem which tell you when there is two manifolds, you are looking two manifolds inside an n-dimensional space. So whether generically they intersect or not, and if they intersect, what is the intersection of the dimension of the intersection? Can there be two planes intersecting in two dimensions? इन टू डायमेंशन खुद एक प्लेन है, तो इसके अंदर जितने भी प्लेन्स होंगे वो उसी के अंदर ही होंगे, ठीक है, वो ये खुद ही होंगे, तो जो भी कोई प्लेन लूंगा तो वो यही प्लेन होगा, क्योंकि R2 खुद एक प्लेन है. So since R2 is a plane, so in the plane, inside the plane, you will get the same plane. No intersection means that there is very less chance of intersection or no intersection. No intersection means that they does not intersect. Yes, there is a very मतलब generally ये जो जितने भी हैं ये generically है कि आपके पास generically there is no intersection. There is a very less chance that you will get the intersection. Okay, so I will stop here. Next time we will start from here, but next time we will see the situation in which one manifold is moving towards the other manifold. Why I'm going to show you this thing, या अगर आपके पास rigid geometry है तो ये सारी बातें rigid geometry के अंदर ठीक है, लेकिन but in the topology we are transforming the different shapes. So transformation में जब आप stretching कर रहे हैं या rotation कर रहे हैं या translation कर रहे हैं, all these are different types of motions. So motion के दौरान क्या आप avoid कर सकते हैं intersection से या नहीं कर सकते हैं, आपके पास इतनी जगह है या नहीं है. So we will see or discuss all these things in the next class. Yes sir, without intersection you are saying, you are आप बिल्कुल सही कह रहे हैं कि आपके पास एक लेस देन वैल्यू n होनी चाहिए ताकि आप एम्बेड हो सके विदाउट इंटरसेक्शन, ठीक है, विदाउट इंटरसेक्शन आप हो सके, आपका ओवरफ्लो जो है वो नेगेटिव होना चाहिए. Can we change that? If everybody is saying about this thing, so we can change the class. हम change कर सकते हैं.
So we can keep a poll on Discord and ask if, because if somebody has issues with different timings, then we probably have to keep it the same. But we'll take a poll so we find out what the timing should be.